Let's show you what vibDaq looks like when it's actually running. We begin here on the vibDaq main screen. It's possible to load and save configurations, but let's start off by configuring the system from scratch. The first thing we will want to do is go to the System Settings section of the main window to configure a variety of system-wide settings. One of our initial settings is the data log file directory. We'll also set some parameters related to order tracking so that we can determine the magnitude and phase of input vibrations as a function of tachometer speed, which can be a very useful analysis tool. Another group of settings deal with FFTs and displaying data in the frequency domain. Some of those include number of lines, averages, and max frequency to show on spectrum plots. Finally, we'll set some parameters to define how often we will write data to log files. We can specify log intervals in terms of changes in time or changes in RPM. Now that we've configured our system-wide settings, we're going to configure our input channels. Here, we'll enter a name for each hardware channel that we want to acquire data on. There are a variety of configuration options for the input channels, including display units, sensitivities, AC or DC coupling, and IE/PE to provide excitation currents to accelerometers if needed. Once hardware input channels have been defined, we can group sensors located at the same point on our machinery into pairs. These pairs can be used for certain plots like orbits or shaft center lines for insight into the two-dimensional motion of our machinery at that point. So now that we have fully configured our system, we can go ahead and press the play button to begin acquiring data. The Plot Manager section on our main user interface allows us to open plots and view data. A plot configuration dialog allows us to choose the plot type and configuration viewing options. First, I will open up a feature table plot. With this plot open, we get general summary information about what is going on with our system. We can also see, back on the main screen, the RPM indicator showing the speed of our tachometer. Next, I will open a time domain plot to view the signal being acquired on channel 2. Once open, I can resize the window, view some summary data to the right of the plot, and probe to find specific values. I can always bring up the plot configuration dialog to change settings, such as axis scaling. Another key plot to view is an FFT, so that I can see my vibration data in the frequency domain. Looking once again at channel 2, I can see which frequencies are most prevalent in my vibration signal. This provides me with a lot of insight into what might be causing vibration in my system.